for today. Iain has travelled to be here, so like I said before, not only are all our presenters volunteers, Iain also travelled as well, so that's like a double whammy. So I want to say thank you for that before he even gets going. Round of applause, come on. So something that's near and dear to my heart, and probably I imagine half the audience as well, home labs, right? Playing with stuff and getting to fiddle and doing it in a way where you're not going to break anything at work is amazing, and that's what Iain's going to talk to us about this afternoon. So thank you very much, Iain.
Good afternoon, everyone. I'll be honest, half of this presentation is about home labs, half of this presentation is dog memes, so we'll get everybody. But yeah, the idea behind this really came about because over Christmas I was a bit bored, decided to renew my home lab, and for those who've read the blog post that I wrote, I've had far too many of them. So this is some of the lessons learned, and the reason I wanted to talk about this is I read a lot of resumes and I do a lot of interviews, and stuff like home labs are a really great experience to talk about during those activities. So I wanted to try and get that across. So that's the wrong one. Here we go. 3 things, nice and simple, what I want to get away from this. What's a home lab? What can I put in it? And how does it actually help me with my job? So a bit about me, because everyone talks a little bit about themselves even though they hate it. I use the tag wanzeronet. According to someone this week, I'm an unhinged rage poster on LinkedIn, which those of you who follow me on LinkedIn probably agree with. I'm starting to get more towards the 20 years in IT and cybersecurity, although the hair was already meeting it. Yes, I'm also one of the founders of CrikeyCon, so we are friends with Crikey, although whether they invite me back after this is another matter. And my life is basically these 2 dogs here, Rose and Zero, who are asleep at home probably right now. Presentation does not represent the views of my employer, even though I haven't talked about them, just making that clear. But it's actually 2 other dogs and 2 other candidates, shall we say, that I want to talk about today, and how a home lab can really apply to them. So, starting with case studies, there's this young man here. He's 4 years old. He has no formal qualifications in cybersecurity or IT or anything. He'll work for basically peanuts, i.e. carrots. He wants to get into an incident response role, and he wants to try and set himself apart. So we've got so many entry type roles. How does someone set themselves apart? Now you notice I haven't said their name until the end. The reason I haven't said their name until the end is because their name is Jarak. That does not spell Jarak. You can blame my parents, they're watching the stream right now. And this is Kudu. Kudu is 9. He's a senior IT administrator. He wants to transition over to that cybersecurity role. He wants to get his first role in cyber. He's an excellent cultural fit and good boy. Kudu means black dog. Jarak means red. There is an imagination here. Now, Kudu is also one of those kind of people that, really learned from his parents. He learned a lot about cyber, learned a lot about IT, as you can see from this picture. Yes, the feet pics are not free. I'm glad I'm getting some laughs out of this. It's great. So, what is a home lab? Definition 1, a garbage disposal unit. Anyone who has a Labrador will know this. Definition 2, an environment to experiment and try out new tech and potentially host it for yourself. Now, Jarak and Kudu have spoken to their friends. They've heard about this wonderful thing called a home lab, and they're interested in seeing how it can apply to them and what they can do. Now, there's a lot of different scope for that, a lot of different things you can do, so this is where we're trying to talk about that information. On the internet, there's a lot of great material out there. There's a lot of things like Reddit, subreddits, our home lab, our sysadmin. There's a whole bunch of other websites. There's also wonderful things like this book. Mummy, why is there a server in the house? This is not fake, it's a real book. It is, however, a little outdated. When a mummy and a daddy love each other very much, the daddy wants to give the mummy a special gift. Doesn't say anything about the mummy giving daddy a special gift, but you get what we're saying. So when we're talking about home labs, what are we talking about? So I'm going to split it up into 2 different sections. There's the physical at home, which is your home lab, and there's kind of the virtual space, which is kind of becoming more important now that cloud is becoming ever present in all our work, and also for just ease of use. Like, it's so easy to spin something up on the internet. These are real examples. This is 3 of the 9 variants of home labs I've had in my years. Top left-hand corner is a EEPC 900HA. It's that netbook thing that came out in 2007. Tiny, quite power efficient, but it was an Atom 2-core processor, so it's pretty crap. You move to Canberra and you learn about Orbids, which is the government auctioning place, or Pickles, and you buy the middle one. You buy a server rack with a whole bunch of Dell R710s, which are power hungry. It has really low partner approval factor, trust me. Power inefficient, but powerful. So those each had, I don't know, 2 12-core CPUs and 192 gig of memory. Never used it all. And then we have the new variant, which is kind of, it's a big thing at the moment. There's a great section by Serve the Home, who's another good source, called Tiny Mini Micro, and these little tiny desktops that you can buy. That's 4 of them. That's not 1, that's 4 desktops. It's a 6-core processor, 48 gig of RAM, giant SSD, whatever. They are 10 centi-zeros per size. Yes, I didn't have bananas for measurement. Quiet, power efficient, powerful. 35 watts. They're about $200, $300. You can buy them on eBay. They're pretty easy to get because basically every business is trying to get rid of them because of COVID. And they're pretty helpful. So that's my choice, but I'm not everyone, right? And the real thing to point out here is your use case will define what you want to find. You could go for that really small Ubuntu laptop. You could just run it on your desktop, your own desktop that you have, your own laptop that you have. Nothing's stopping for you. Get VirtualBox, get VMware, just run it. It's just getting to it. And a lot of people think it's quite difficult, but hopefully I'll be showing that that's not the case. Or your home lab can be in that nebulous thing we call the cloud, which is made up of other people's computers. Basically, every single provider that has cloud has a free tier. So Amazon's got, it's basically a really tiny VM for 12 months and a whole bunch of services. Azure's got $200 plus VM, blah, blah, blah. Google Cloud, $300 for services. Oracle's probably the best at the moment. You can get a VM and also a ARM bare metal box for free. You can just sign up, they'll give it to you for free. They'll take it off you if you don't use it, but you can sign up and get it for free. DigitalOcean, Volta, 2 not really known, but they're kind of in the medium scale space. Credits with referrals. If anyone's interested, yes, I have a referral, I can provide that. But all of that's free. So all the infrastructure you can get is free. It's really easy to get. You can have a VM, you can have Kubernetes clusters, you can have Docker containers, whatever you want, it's all there. So a bit of context, I guess. Why do I have a home lab? I'm apparently a manager these days, which I don't like, but we'll go with it. But I still need to be able to talk tech. I still need to be able to communicate to my team. I need to be able to communicate to managers. So for me, as a bit of context, I'm looking at evaluating tech and architectures. So brand new things in security, orchestration, case management, XDR, which by the way is just EDR rebranded, which is just SIEM rebranded. Sorry if anybody's listening from a vendor. And the other part of it is cloud architectures and, as a service. Like, we've got this great, wonderful thing called cloud and as a service, and as a security person, it means bugger all to me, but it means a lot to IT people. So if I'm going to do cyber with that systems, I need to know how it works. And that kind of goes to the next point. Containers and Kubernetes, cattle not pets. It's a big thing to make sure that you're treating things not as that one server that you install everything on, you've nurtured, you've made sure it survives throughout the years, and then 10 years later you turn it off after it's been up for forever and it's been hidden behind a wall in the server room. Infrastructure as code. So being able to just write code, everyone being a software engineer, is pretty amazing, to be honest. And then declarative and immutable infrastructure. So for those who don't know, declarative is basically saying, I want the state to look like this. It's not how you get to that state. I don't care how you get to that state. Just make it like this. And it's a really powerful tool when you're doing baselining. So if you say, I want the state to always look like this, no matter what, then you can baseline that really easily, because it's either that state or it's not. Whereas with, I believe the alternative is imperative, and I could be wrong, you say, run this command, run this command, run this command, run this command. You never know where you're going to end up. You don't know what it's going to look like. You can make a best guess, but you don't know. And immutable is a great, wonderful thing, which is you cannot change the infrastructure. So you install an operating system, it does not change. You can't change it. You have to rip and replace the whole thing from scratch. Which has, if you can think about it, some interesting implications for cyber. And then I run a whole bunch of my own services. I'm a nerd who runs an identity server. NetBoot's great for if you have to have people come around and fix their computers and you just need to boot a Windows machine and whatever. Splunk and Elastic just because who doesn't want to run their own SOC at home? But why could you have one? By not having read-only Fridays, like this gentleman here learnt. That's a bed, by the way, that he's ripped to shreds. Capture the flag competitions. If you're running Kali on your laptop, you're probably in the category of home lab right now. Okay? Machine learning. Everyone seems to want to run their own LLM at the moment, and that's probably going to make GPU prices go through the roof again. Glad I bought mine last month. As our fine host told us, providing you with an environment to break stuff. Now, companies generally don't like it when you break their infrastructure. So having a space to do it yourself is a great place to do it. Learning Windows Tech, I've put that there not because of any particular reason, but it's not just about Linux, it's not just about, Docker, etc. Learning Windows, learning AD, learning DHCP, learning how all those things work, because basically every environment right now, even if it's cloud, has an on-prem AD server. I will guarantee it in most cases. And then if you buy that server rack, it's warm. It'll keep you warm. Canberra's pretty cold. Brisbane's not. I'm melting here. That's fine. But how do I use it? All right, so we talked about this wonderful thing. I don't want to just tell you it's amazing, tell you it's wonderful, and then not tell you how to do it. Oh, I'm way ahead. Perfect. But before I start, have one note. We all have our favorite religious war. How many people in here, put your hands up if you are Vim users? How many are Emacs users? How many use not a Visual Studio Code? Yeah, perfect. It's not a religious war. I've picked the technologies that make sense for me. There's a bunch of reasons why you would pick certain technologies. A great example is I picked Terraform. Terraform has an alternative called OpenTofu, because Terraform decided that people were selling its product and wanted to make money. So if you want to use OpenTofu, go for it. The idea behind this is to provide you the concepts that you can go with and see, it's actually easy. And yes, this gentleman here likes all of them. And Nano. Nano's amazing, I'm sorry. I gotta say it. Nano's the best. So a nice simple example for you, and I'm gonna talk about 4 or 5 different tools. So Tailscale, if you haven't heard of Tailscale, it's amazing, it'll change your life. Terraform and Proxmox. For those who've been keeping up and you have ESX boxes, you're going to have to do a transition soon. So you might want to watch. And then Ansible and Kubernetes, because Ian Coldwater posted the other day, Kubernetes is how you make friends in your 30s. So I'd like to make some friends. So before I get started, because I stupidly decided that I was going to do a demo, as anyone knows, and who's ever given demos before, it doesn't always end well. So when people are coming in, we're going to do a little bit of a sacrifice, and I'd like you all to join in for a second, because We really need to have that atmosphere and that positive energy to make sure the demo works. I've chosen a Susan of Bundaberg rum because I believe that is the town for it right now. So what I just want everyone to do is, keep positive, say wonderful things. If you know, as Terry Pratchett said, a magic prune, feel free to say it. But we'll just, yes, that's perfect. And yes, I did literally get off a plane from Canberra this morning, go to Bunnings and buy a bucket. That is how dedicated I am. I spilt a little, I'm sorry. Can't believe I did that. All right, tail scale. This is the one thing I'm not going to show you live because I don't trust you. Tail scale's great. What it does is it's basically, the easiest way I can describe it is it's a management interface for WireGuard. If you haven't heard of WireGuard before, get off IP, IP whatever, and use it. It's great. What it will do is it will manage the creation of a mesh network entirely for you, magically, wonderfully, amazingly. It will also allow you to use it as a transit piece. So you notice, now we'll see if the technology works. It says here, in this one, subnets and exit node. What that means is, when I'm connected to Tailscale from my laptop, subnets means I can access any machine that sits on that subnet. And that just so happens to be my OPN sense box. So I can log into absolutely anything on that with no issues whatsoever. Now that doesn't sound great, that doesn't sound amazing, VPN's been doing that for years. The point is I can do it from the same DNS entries. So my DNS points to that, everything goes to that DNS, I don't have to change anything, I just go same DNS entry. For those who've had to do with DNS before, it's amazing, please use it. The only embuggerance is it does use carrier grade NAT ranges, if you know what those are, so 100.x.x, well, 100.64 technically. So if you're on carrier grade NAT, I haven't tried it, but it does cause some issues. Buyer beware. Yes, I'm aware that the version here is vastly out of date and telling me that it needs updating. I believe the person who caused that to happen is in CrikeyCon right now because they did the vulnerability for it. Hey, Emily, I thought it was you. The reason I don't do that is it's a Steam Deck, so what the hell do I care? Ah, right. Now I have to actually get something to work. I promise I won't move any further. So, all right, so I'm going to cheat a little because installing Proxmox is the hardest bit. You basically have to boot Proxmox, install it, give it an IP address, and set up storage and do all that. You can't automate it. I'm trying to. There is ways to do it, but because it's bare metal, it's a bit of a pain in the ass. You'll notice I have 6 hosts because 3 wasn't enough, so I needed 6. But basically, this creates a cluster. If I open it here, it says I have 36 CPUs and 281 gig of RAM. That's okay, cool. So this is what you would, this is kind of, to put it in terms for people who, I hate to say it, are as old as me, this is kind of like your ESX and your vCenter. So you don't need a separate vCenter, it does it for you. It's built into the system, which means no wasting 14 gigs of RAM on vCenter, which is quite helpful. So what I'm going to do is, I've got a nice simple script here. I will point out it is not secure, because I am a security person and I don't do what I say. So you will notice that host key checking is turned off. Now that's because of a whole bunch of reasons and a whole bunch of issues that happen when you're using reproducible infrastructure. It just happens. What it's going to do is it's going to run Terraform, so it's going to create a Terraform plan. It's going to create it. It's going to go to Ansible and sleep for 120 seconds. That's not to give me time to talk. That's because I've found there's issues when you use Terraform to build a VM, and then you don't wait long enough for Ansible to kick in, and then the package manager gets in a really crappy mood. So that's for that. It's going to do 2 Ansible jobs, which you can't see. One is to replace a thing called machine IDs, which is a weird, obtuse thing that doesn't really matter unless you're trying to run the exact Kubernetes distro I'm trying to run. And want to do an update, and then it's going to install Kubernetes. I'm not going to... Does everyone know what Kubernetes is? Kind of. Kubernetes is just overcomplicating orchestration. That is the answer. Unfortunately, it's the best at complicating orchestration. So I'm just going to run that script, and while it runs, so it's just done a plan, it's now creating. So I'll just go through one by one and talk about each one. So Terraform is great. It's a product by HashiCorp. As I said, there's been some issues in terms of licensing recently, but it's still a good product. What it allows you to do is define in a declarative sense, as I said before, what you want at the end. Now, I have said it wasn't me, I didn't do it. So you define what you're doing. So I'm doing something with Proxmox, and I'm doing something with 1Password. I'm not actually doing something with 1Password. It turns out it's broken. But you can use 1Password as a password store secrets manager. Who knew? I'm going to tell it to connect to Proxmox, and then I'm going to tell it I want 3 VMs. So count equals 3, name them demo 1, 2, and 3. I tell it where to install them, and I give it a bunch of information that says, you know, it's going to have this IP address, it's going to have this operating system, 2 cores, 8 gig of RAM, a 30 gig SSD, blah, 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 blah. And all this is documented. There's a heap of Terraform providers, they're called, plugins essentially. And those plugins are for Amazon, those plugins are for really obscure things. You can find heaps of them, and they're open source, so they're great. Noting the fact that 2 minutes hasn't finished yet, we'll go into Ansible. Nothing can go wrong. It'll break eventually. So Ansible, again, is declarative. Great, you'll see this as a theme. I really like declarative because I can basically say, I want it to look like this, and I don't care how you get to that state, it's just going to get to that state. So what we're saying here is run apt, update the cache, update packages, check if a reboot is needed, and reboot the box. It's pretty simple. Again, Ansible packages for basically everything. Ansible is also in the Red Hat Automation Suite. It's owned by Red Hat now, which you can take as good or bad, depending on if you like IBM or not. And yeah, so this one's doing one that says update the apt repo, and the other one is doing one which says there's some weirdness with machine IDs. If you download an image, because, sorry, I skipped ahead a bit. I've not installed Ubuntu for this. Ubuntu offers a cloud image online. It offers an image on AWS, it offers an image on Azure, whatever you want. You can just use that. You don't need to spend time installing it. You just use that image, as long as you kind of trust Canonical. And what has Mark ever done wrong? So right now, it's running a whole bunch of things. You can see I've not run the proper commands. It says, don't do an RM command. And I'm like, I don't care. I just wanted it to do what it's told. It's now rebooting the machines. We can check that because we can go to here. These are the 3 machines. All right? So in, 5 minutes, 2 minutes, I've built 3 machines. There is a bit of a bug, which is I can't see the console. That's a weirdness with UEFI and consoles. And I will talk more about that later. It's now updating the app repo. So it's now going through, like a minute later, it's doing the app repo. This is riveting stuff. I watched this for hours, all right? To make sure if something breaks. Because I'm not the guy who like goes through and checks it. It's like, no, I'm going to run it in prod and see if it breaks. Now we're up to KOS. So KOS is a distribution of Kubernetes. Like Linux, we have distributions of Kubernetes. The trick is they're all basically the same. There's no difference. They're all the same binaries. It's just the config is different. So you'll hear terms like Rancher and K3S and microcates and blah, blah, blah. It doesn't really matter, just pick one. I picked this one because the joy of running Rancher, if you've ever heard of it, is Rancher uses a 10.42 address for its cluster comms. Unfortunately, I am just as much a nerd as Rancher, and I run 10.42 as my internal network, so routing does not work. Bloody nerds. So right now, it's basically installing. I've given it the 3 machines. I've said, go install Kubernetes, go make it happen. It's now finished. And for those who've seen kubectl, which is a great, wonderful application, it now says I have one controller and 2 workers, which means I'm amazing and wonderful, and I can do data center management and stuff. It's a bit more complicated than that. You can apply manifest, you can make sure you install the right storage, et cetera, et cetera. You get the point. And then because I don't care about you seeing certificates, I can go like this, which is the main config for Kubernetes. I can open a wonderful application by a company called Mirantis. I can go here. It's going to connect eventually. By the way, if I hadn't pointed it out, this is VMing back to Canberra, so it's a little slow with the kangaroos. We don't quite have internet over there. And then I can start, I've got nodes. Great. I can install applications. Great. So I've basically got the whole thing built in about 7 minutes. Admittedly, it did take about a week to write the config. But the point is, it's written. You can now use it as much as you like. If you break something, you just reinstall the cluster. There's no point trying to fix this stuff. And that's kind of the new mentality that comes along with IT. We have finished the demo. Can I move on? Thank you. All right, that's great. Wonderful. I've shown a whole bunch of blinking lights and terminals. How does that actually help me? I'll just let that one sink in. Again, cattle, yum, yum, yum. So cyber is all about securing IT. If IT didn't really exist, cyber probably wouldn't exist. It would probably be still called information security, and we can have that argument till the cows come home. But without the IT systems, without the way that we do IT, you can't do cyber. So to do cyber properly, you need to understand those IT systems. So when you've got a whole bunch of DevOps people and they're fresh out of uni, sorry, uni people, and they're talking about, I'm going to run a Kubernetes cluster, it's going to be immutable, I'm going to have containers, I'm going to do this, I'm going to do that. It's like, whoa, hang on, how does that actually work? So some of the interesting challenges that come with these new IT things, and these are things that I've been coming up with and why I started, how the hell do I actually run incident response on containers? So I've got a container. The container doesn't change. The container is supposed to be fixed. So how do I actually get the artifacts that I need off that container to actually do any sort of competent incident response? How do I gain visibility of traffic on a Kubernetes cluster? So I've got a whole bunch of containers. Normally I'd have a whole bunch of servers, a whole bunch of VMs, and what I do is I'd either set, may it rest in peace, NSX on the ESX server, and I would tap that network, but I can't do that on Kubernetes. It's all just ephemeral rubbish. How do I actually gain visibility of that so I know what's talking to what and how they're talking, and how can I make sure that that's the right way they're talking? What does the cattle paradigm mean for attainment of artifacts? Kind of the same as containers, but if I'm repeatedly building, destroying, building, destroying, building, destroying stuff, how do I know and make sure I'm keeping logs? How do I know and make sure I'm keeping artifacts? How do I know and make sure that what I'm building is correct? So a great one to think about is if your entire infrastructure is driven by a Git repository, what do I need to do to compromise that infrastructure? Compromise Git. And I change the code in the Git repo. Because even though people do DevOps, they don't do DevSecOps and they don't verify the Terraform. You can do it, it's been done. And how do I get rid of malware on immutable infrastructure? How do I get rid of something on something that's not supposed to be deleted? So there's a lot of good experience. The other great thing is we talk a lot about CTFs are great for like pen testing experience, and we've had the CTF here at CrikeyCon. We have CTFs everywhere, hack the box, et cetera, et cetera. And they're really great for demonstrating sort of red team, maybe a bit of blue team if you're doing the IR CTF from ACSC. But if you're doing architecture or engineering, it's really hard to demonstrate that you know what you're talking about by doing those CTFs. All right? The challenges aren't really focused on architecture people. So what is the alternative? And I'd like to pose that the alternative is, you know, I've built a network at home, I've done it in this way, I've shown how I can do it in this kind of methodology, in this way of building, etc. That should example. You know, building your network is not necessarily just, I'm doing it for fun. It's an actual way of demonstrating real life experience. I thought I'd put a bit in here about resumes. Resumes are boring, but, you know, ultimately, it's the first thing that someone sees. Like, I go through hundreds of resumes, and there's a lot of bad ones, but there's a lot of good ones. And the key thing that I always say is proof points are critical. STAR is not an APS methodology. I don't know why I said that, but STAR, if you've heard of it, is situation, task, action, response. It is a great way of describing on your resume how you've done something in your experience. So, and as an example here, you know, Jarek has been at work. He's asked to automate the deployment of a development environment, built code using Terraform and Ansible, deployed VMs, made them work, boom, perfect. Which is really easy to do, by the way. The other thing I didn't mention, you can do all this in GitHub code spaces for free. And if you use Tailscale, you can connect your GitHub code space to your home network. Wow. Sorry, I went too far. All right, so closing out because time works well. Home labs can be tailored to your circumstances. Home labs are not just about investing thousands and thousands of dollars and crying in a corner and then trying to write a presentation to justify their existence. No. You can tailor it towards your money, time, technology. A common thing I've been talking to people about is, you know, I have parental responsibilities, you know, I'm looking after them. How do I, like, put this in my life? Like, it's really difficult. And I'm like, yep, totally understand. And in that case, it might not be for you. But if we can decrease the amount of work you need to do, maybe it'll be easier. And by learning IT administration tools, because basically that's all I showed you. I didn't show you any cool cyber. I'm not amazing like Louis in doing vulnerability assessments. I don't do that. I just do IT. But basically, I've got to cyber all that IT. I've got to secure all that IT. And that's the important thing, right? The IT is going to keep changing, but we need to learn how to secure it. And so if we can do that, that's much better. As a reference, every piece of code I have written for this demo is in that Git repository. I promise it does not go to Rickrolling. If you are interested in hearing more, then follow my rants at WanoNet. There is a website. Finally, because I'm a horrible person, when the CrikeyCon crew come up at the end, applaud them. It's an amazing amount of work to run a conference, and I know because unfortunately I'm stupid enough to do it myself. So make sure they get a suitable amount of applause. Thank you very much, everyone. I'm going to run away now.